Hello everyone, this is Harleen Kaur and today we are going to talk about early discoveries on structure of atom. So the very first discovery for the structure of atom was made by J.J. Thomson. J.J. Thomson gave certain points about the structure of an atom and those points together constitutes the J.J. Thomson's model of atom. So today, first of all, we will discuss what J.J. Thomson stated. So according to J.J. Thomson, he said that atom is a sphere. That means he talked about a three-dimensional structure of an atom. Atom is a sphere and that sphere carries positive charge on it. So atom is considered as a sphere that is carrying positive charge, and those positive charge is because of the presence of protons in the atom. So this means the very first thing that J.J. Thomson stated was that atom is composed of positively charged particles, and those positive charged particles are protons that we have already discussed in the earlier video. So positive charge on an atom is due to protons, and at the same time it carries negatively charged particles also, and those negative charged particles are called electrons. Now the very important and very interesting thing about J.J. Thomson's model of atom is that he related his model, or he visualized his model as a cake or as a pudding. See, J.J. Thomson's model of atom just looks like a plum pudding model. Like in this structure, if you see that like in this structure, there is a cake in which dry fruit or cherries are somewhere embedded in it. They are distributed uniformly in certain parts of the whole cake structure. Similarly, in the J.J. Thomson's model of atom, he said same, like this red part in this figure. This is what? This is protons, or we can say this is positively charged sphere, and these blue balls that are represented, they are what? Electrons. So J.J. Thomson said that in a sphere of positive charge, electrons are embedded in an atom, just as cherries or dry fruit is embedded in the cake, or you can say like the cherries are distributed in the Christmas pudding. Right. So the very first thing that Thomson talked about was that atom is composed of protons as well as electrons. The second point that he discussed was that protons are a sphere, positive charged sphere, and in which electrons or the negative charges are embedded in it. Right. So moving on further, Thomson stated one more important. What was the important point? That important point was that the mass of atom is considered to be evenly spread throughout the model of. That means every part of the atom weighs equal. So the mass of the atom, it is distributed equally among the whole region. But there was one point that could not be discussed by Thomson, and that came out as a drawback for J.J. Thomson's model. He could not explain the neutrality of the atom. How he could not explain the overall neutrality of the atom? Let us discuss about that. So we just talked about that atom is a positively charged sphere in which electrons are embedded somewhere. Now this is just like watermelon. The red part of the watermelon is basically the positively charged sphere, and the small black colored seeds in the watermelon are considered as electrons. Now see, the red part in the watermelon is more, and the seeds or the black part in the watermelon is comparatively very small, right? So this explains that the positive part of the atom is large and negative part of the atom is less. So how come atom can be neutral? So J.J. Thomson, after certain point of time, said that the magnitude of positive charge and the magnitude of negative charge is same. But he could not explain the experiments which were carried out further. Further experiments that were carried out by Rutherford, like alpha scattering experiment, that is the next part of our video. He could not explain the results of those, so J.J. Thomson fell short of the structure. Hence, it was considered as the drawback of J.J. Thomson's model of an atom. So after this J.J. Thomson model of atom was discovered, or certain points were discussed about this model, many other scientists, they started carrying out many other experiments, and one of the important experiment was carried out by Rutherford in 1911, and that experiment was Rutherford's alpha scattering experiment. This Rutherford's alpha scattering experiment is one of the important experiments to be carried out while studying the discovery of an atom. So what he did was, Rutherford in 1911, he took a gold foil. Now the very first thing is why he took the gold foil. We know that gold is a highly malleable metal. Highly malleable means we can convert it into a very thin sheet, as much thin as we want. So he took a gold foil, he made it extremely thin so that the atoms do not collide each other, or however thin he can do so. And then he started striking the fast moving alpha particles on that structure, alpha particles. So he started supplying a fast beam of alpha particles on the gold foil, and that gold, whatever the alpha particles were, their path were then studied with the help of a fluorescent zinc sulfide screen around it. Now let us see how the setup was made. This is how a setup of alpha scattering experiment looks. So this is what this box, it is a source of alpha particle. That means that whatever alpha particles are being made to fall on the gold foil, they come from this box. So this box is a source of alpha particles, and then we have a thin gold foil in the center. This thin gold foil was made to strike with the alpha particles. Again, there was a small slit over here, small slit in the region, in the path, so that whatever alpha particles are coming, they come as a beam of particles, or a beam of ray. So these alpha particles, when they were made to fall on the thin gold foil, as you can see in the figure, some of the rays are going straight, while some are getting deflected from their path, scattered, while some of them, they get scattered so much that they almost deflect at an angle greater than 90 degree, and there were very few particles which were coming back. So basically what happened, when the source of alpha particle emitted the alpha particles, and these alpha particles were made to fall on a thin gold foil, they started deflecting, while some of those also scattered at an angle of greater than 90 degree, and most of the particles, they got undeflected, and they directly uh, moved in a straight line. So what are the observations made? These are the observations, that some of the alpha particles, they passed without any deflection. Some alpha particles, they deflect but through a small angle. and very few particles were deflected at an angle of almost 180 degrees. So from these observations, what Rutherford concluded is the very important point. So Rutherford concluded three main important points about the structure of an atom. Now let us talk about those conclusions. What conclusions were made by Rutherford? So Rutherford said that most of the alpha particles are being undeflected, right? So this means that there is a lot of empty space within the atom. क्योंकि अब अगर कोई चीज डिफ्लेक्ट ही नहीं हो रही है, मतलब उसके रास्ते में कुछ आ ही नहीं रहा, कुछ नहीं आ रहा, तो क्या मतलब है? It means that it is empty, right? So he said that since most of the alpha particles they are passing straight, and passing straight means that they are not getting deflected, and not getting deflected means there is so much of empty space within the atom. Moving on to the next conclusion, we saw that only few particles they were getting deflected by certain angles, small angles. This means that there is certain thing present inside the atom which is deflecting them. Deflecting means which is repelling them. Now what are alpha particles? Alpha particles themselves carry positive charge, right? And if they strike a positively charged thing, they are obviously going to repel them. So whenever alpha particles got deflected by small angles, it means that they are striking something positive. This means there is a certain thing present within the atom which is positively charged. And what that positively charged is, that positively charged thing is proton, but nothing else but proton. But at the same time, very few particles are getting deflected. Now, very few particles are getting deflected means the positive charge is concentrated at a very small space. And that small portion of an atom where protons are present, it was known as nucleus. Again, next part, since again we are talking about very few alpha particles are being deflected, or very few alpha particles are being deflected at an angle nearly 180 degree, this means protons are present in a very small region. Very small region means the nucleus is very small. The volume of nucleus is very small in comparison to the total volume of the atom. Atom itself is very big, but nucleus is very small, a small part. Just like if we have a circle or a sphere with radius, let's say 10 centimeters, so a one single small dot will represent the nucleus. Right? So these were the conclusions made by Rutherford. So from these conclusions, he put forward the model of an atom. And what was that model of an atom? It was known as Rutherford's nuclear model of an atom. And what it says? It says that the positive charge and the whole mass of an atom, it is concentrated in a very small region, and that small region is known as nucleus. And whatever region apart from nucleus is there in the atom, that region is known as extra nuclear region, and that extra nuclear region carries what? It carries electrons. Extra nuclear region carries electrons. So it is just like this is the center of an atom and it is nucleus, and this is a whole atom. It should be circular, right? So this region outside the nucleus, this is the extra nuclear region, and in this region electrons are present. And Rutherford also said that these electrons revolve around the nucleus just like planets revolve around sun. So I hope you can understand, if this is sun and the planets, they are revolving around it in their own paths. Similarly, electrons also do the same. They revolve around nucleus in certain circular paths, and those certain circular paths were known as orbits. See, Rutherford has discussed the discovery of electron also. He has discussed the inclusion of protons in the nucleus also, and he has talked about the inclusion of electrons in the atom also. But again, he didn't talk about neutrons. But what was the major drawback of Rutherford? Is this the best model, best explained model of an atom? No. There are certain drawbacks that Rutherford's atomic model has. Now let us discuss those drawbacks. So the very first thing that Rutherford could not explain in his model was its stability of an atom. He could not talk about stability of atom. Now let us talk about how he could not explain the stability of atom. To explain this, I will take one simple example. So since we are talking that this is nucleus and electrons are revolving here, right, in outside the nucleus. Now if the electrons are revolving around the nucleus, don't you think that the electrons may get tired and they will start losing their energy? And if they will start losing their energy, there will be one time when they will come like this rotating and they will fall into the nucleus. And when all of the electrons they start coming inside the nucleus, there will be one time when there will be only nucleus and no extranuclear region. Hence, the atom will collapse and there will be only nucleus, nothing else. Right? Only nucleus and nothing else. This means after a certain point of time, atom will destroy and whatever we will be left with will be just nucleus. But this doesn't happen. So Rutherford could not explain that how the electrons are moving inside the atom around the nucleus and even then they are not losing their energy, and how come they do not come and fall into the nucleus, and how atom is stable. So Rutherford could not explain this phenomenon at all and hence it failed. So this is one of the major drawbacks that Rutherford could not explain about the structure of the atom. Right. So with this, I have covered J.J. Thomson's model of an atom and Rutherford's model of an atom. The next thing that we can talk about is Bohr's atomic model that we have already discussed in class 9. But before that, before Bohr model was discovered, there were many other discoveries made which were very important for Bohr model to come into existence. So in the next video, we are going to talk about those important discoveries that were made by different scientists before Bohr could establish his own atomic model. So with this we come to an end of this video, and let me know if you have any doubts. Your question will be, what are the drawbacks of J.J. Thomson's model and Rutherford's atomic model? What is extranuclear region and what subatomic particle is present in this extranuclear region? And one last question for you guys will be, Discuss the stability of an atom on the basis of Rutherford model. So you will talk about how Rutherford's atomic model could not explain the stability of an atom. Basically, this is same as the drawback, just the wording of the answer will change. So let me know how you explain it. Thank you everyone. Any doubts can be taken anytime. Have a nice day.